talk eclipses. Now, eclipse means that one of your celestial objects, either the Earth is casting a shadow on the moon, or the moon is casting a shadow on the Earth. So something's blocking the sun. Looking at lunar, lunar means moon. So the moon is being eclipsed. The Earth is casting a shadow on the moon. Now, since the Earth is larger than the moon, the whole moon will be eclipsed. In order to have this, I need a full moon. So remember, sun, Earth, moon. The whole idea is, for this one to occur, I would need the Earth and the moon to be on the same plane. We don't have a total eclipse or a lunar eclipse every time we have a full moon, because the moon and the Earth are normally about 5 degrees off their planes, so they don't perfectly align. When they do perfectly align, that's when we're going to get our eclipses. Now, our next total lunar eclipse in North America is in approximately a year. So May 26, 2021. Let me talk really quick. Umbra and penumbra, they're shadows. So if I have you go outside and cast a shadow, you'll notice that your shadow has two parts. That dark part and that gray fuzzy area around it. That dark part is your umbra. That gray fuzzy area around is your penumbra. So this one, if you look at your lunar eclipse, it almost looks like you've gone through your phases of the moon, but you've gone through it in minutes instead of days. Full moon and you're getting less and less illuminated. Right? This is considered totally dark, and then you'll see you're getting more and more illuminated. And then the picture cuts off. Solar eclipse. With a solar eclipse, the moon is casting a shadow on the Earth. Since the moon is smaller than the Earth, not everyone on the Earth is going to get the solar eclipse. So for that one, if I'm looking at the phase, the moon must be in a new moon phase. Because here's the sun, it's illuminating this side of the moon, so the opposite side would be dark. So it's got to be a new moon phase. The next one for us, United States, April 8th, 2024. This is the one a few years ago that everyone was running around and getting their special glasses so they could actually watch the total eclipse occur. So the next time, if you're looking at the diagram on the right-hand side, it's showing you where the total eclipse will be. That's your green line. Within your gray and your yellow, you're pretty close to being a total. Just a sliver of the sun will be showing. So if you're looking at Syracuse, we're pretty close to being total. Just north of it would be a little better towards Watertown or going out towards Rochester, Buffalo. This too is showing you how you're getting your eclipse of your solar. So it shows the moon actually casting its shadow on the Earth. All right, next we're going to look at tides. Tides, you're looking at the rising and falling of water. More or less ocean or really large lakes. Lake Ontario, your Great Lakes would work. If you're looking at your Finger Lakes, too small, not going to have a huge effect. So the rising and falling of the water due to change in gravitational attraction between the sun, Earth, and the moon. And that all has to do with as the Earth is revolving around the sun and the moons are revolving around the earth, with the changes, you're going to get different pulls and gravity. So the first of the two tides we're going to talk about are neap tides. That one, for this one, here's my earth and my moon is either in what? First quarter or last quarter. The moon is pulling this direction, so the water on the earth, the moon is pulling it towards it. Alright, so you're going to actually get a little bit of a bulge this way and a little bit of a bulge this way. So it's pulling it from here up or here down. Where the sun is pulling this direction. So it's trying to pull the water from here towards it. Now, you would think the sun being so much larger, that if it was a tug of war, the sun would win. Here's the problem. The moon, although a lot smaller, is so much closer, and because it's so much closer, it has a greater gravitational attraction. So the moon wins slightly. So if I look at my high tide's not really that high. It's considered a low high tide. And my low tide is not really that low. It's considered a high low tide. What you don't see is a huge difference between your high and low tides from a normal location. Next one, I'm talking spring tide. Alright, with a spring tide, you're either a new or full moon, and the sun and moon are working together. So they're working in the same plane. So they have a greater pull. They're pulling the water, the sun would be pulling the water this direction. So your high tide's really high, and your low tide's really low. Alright, so this is the Bay of Fundy up in Canada. Here's your high tide. Here's how far it's dropped with your low tide. And this is what I'm talking about, how they have a pull. So you see how the water from here gets pulled, or from here gets pulled this direction. So you have a bulge. Alright, so with this one, your moon and the sun are working together. Highest of your high tides, lowest of your low tide. It's going to be your spring tide. This one, the sun and the moon are working opposite each other. The moon is going to win slightly. So your high tide not that high, and your low tide's really not going to be that much lower. Alright, we need to talk about the three theories, what scientists think how the moon was created. So the first one is the collision theory. The whole idea is you had a rogue planet. At the time that this was occurring, you had a lot more material flowing throughout the galaxies or the universe. So things were knocking into each other, colliding into each other. So there is some thought that you had this random planet that they call Orpheus. They came and collided with the Earth in just the right angle that it hit part of it, and then it caused part of it, the Earth, to blow off, and then it came back and hit the Earth again. Not dead on, but off on just a slight angle. With that one, it caused the material to explode outwards. With that, the material made it out far enough that material didn't coalesce or come back into the Earth. So with that one, you were able to actually form a moon outside the gravitational attraction. So that's one theory. Second theory, capture theory. That the moon was actually captured by the Earth's gravitational field. If you look at it, scientists looked at that one and said, something that big, not happening. So physics-wise, it didn't make sense. Third one, Earth was molten material at the time. It was spinning so fast that a chunk of it actually came off. Now, with that one, the problem is, if that was true, it was all the same material at first. So composition-wise, the moon's composition should match that of the Earth. And it doesn't. Doesn't match completely. There are some similarities, but there are also some differences. So scientists actually go with the collision theory, which would help explain that although Earth and Moon do have some chemical compositions that are similar or the same, there's also little differences. Because what you're doing is you're taking in material from another planet that actually was part of the moon. So the theory that they actually go with is the first one, which is the collision theory.